Welcome back, guys. Let's talk about another breaker. This one is called MCCB. The last one was MCB, this one is MCCB, so pay attention, don't get confused. Well, to be honest, they work kind of the same, but the difference is that MCCB breaker supports a very high electrical current. And compared to MCB breakers, this one actually has some additional sub-items, you can say. Well, as for the similarities with MCB, this one also protects the circuits against overloading and short circuits. Alright, now let's talk about this breaker in more detail. Alright, first off, we have a switch here, and it could be set in 3 modes: on, off, and trip. Well, obviously anyone knows what happens if you go with on or off. So let's just talk about the third mode. Well, first off, guys, in this situation, the breaker has in fact detected a short circuit or an overload. And by the way, guys, this third mode, the trip mode, would be set somewhere in between the on and off mode. Now let's try elaborating on this even further. As you can see, we have 3 types of trips. For example, let's talk about magnetic trip. Yeah, this one would appear if a short circuit was detected by the breaker. And then the second one, thermal trip, would appear or would act if we had an overload. And number 3 would be manual trip. This would happen if we set the switch on trip ourselves. Because, for any reason, because we had to, basically. And by the way, there's actually a specific method for doing this. For setting the switch on trip manually. Like, there's this red button here. You can push this down. And, this way, the switch would be set on trip. More specifically, manual trip. Okay, let's move on. In the next slide, guys, we would see 2 symbols. One for thermal elements regarding overload, and the other one for magnetic elements that would be for short circuits. And what is important for us regarding these 2 symbols would be the fact that when we combine these 2 symbols, we can actually create a symbol for MCCB breaker. Now let me give you a demonstration. For example, we got an MCCB breaker symbol, single line. Okay, this one is also a single line MCCB breaker symbol. This one is used for circuits with high electrical current. Then here we got a multi-line MCCB symbol containing symbols for both, overload and short circuits. Okay? And, by the way, the symbol that you can see here would be the American version, based on the NEMA standards. And, guys, we have some more peculiar symbols that you can actually see here. Like, this one is used for draw-out circuits. And again, don't forget, we're still talking about the NEMA standards, the American symbols. And this one is, for example, used for fixed circuits, okay? Moving on, guys, there are some auxiliary features to these types of breakers. Like, for example, MCCB breakers actually have auxiliary contacts. Alright, let me try to give you a further elaboration on this. Let's say, for example, the switch is actually on here. Let me write it down. In this case, the normally open contacts that we have would be closed, and, exactly in reverse, the normally closed ones would be opened. And yeah, basically this could be counted as an auxiliary feature that we have in such breakers. Also, guys, another feature or, a sub-item that we have in such breakers is called fault contact. Well, as you know, guys, for any reason, we might have problems such as short circuits or, overloading in our whole system. And this is where exactly we can use fault contacts. Now they could be specified by numbers such as 95, 96, 97, and 98. And when the switch would be set on trip, well, these would react. And you know the drill basically. Normally closed ones would open and normally open ones would close. And by the way, guys, when it comes to using these in control circuits, these contacts could actually be connected to signal lamps to, well, find out what exactly is going on with our breaker. Okay, guys, there's an additional feature or an item that we actually we can have in an MCCB breaker, and it is called the Shunt Trip. All right. Now the question is, what exactly this does for us? Well, as I said, this could be set in some of the MCCB breakers, and after that, when it gets a signal, we'll get the ability to control the switch. For example, set it on trip from a long distance.